Okay, CloudFront, that is CDN. CloudFront is the brand name from Amazon, and this service is about CDN. CDN का मतलब होता है कंटेंट डिलीवरी नेटवर्क. ओके, शुरू करने से पहले आपको नेटवर्किंग का थोड़ा सा बेसिक कॉन्सेप्ट बता दूं मैं, देन विल मूव फॉरदर. देखिए क्या होता है, whenever you're trying to access any resource over internet. अभी हम जो भी रिसोर्स यूज करते हैं और एक्सेस करते हैं वो वाया इंटरनेट करते हैं. So you are here as a user, this is a laptop machine, you are connected to the internet, right? Through some ISP, right? So when you're trying to access any resource like Google server, Amazon server, right? So your communication, see, you yourself are in a private network, right? Your communication starts, goes to the ISP router, and from there it goes to next router, next router. Internet is what? It's a series of networks interconnected through routers. Routers are the devices joining, connecting all these networks together. Yes. So you are saying google.com. We even don't know what is the location of this google.com, whether it is here in India or it's there somewhere in a different country, right? But we are connected, we are communicated, right? Now, when we use this internet, the plus point with this internet is that it's widespread, right? जैसा शायद मैंने पहले भी बताया होगा, we always feel connected to the rest of the world wherever you are roaming around via internet. But the negative side is what? That this is a public network. It's a public network. It's all open to the public, right? And so, with this nature public network, there are lot many shortcomings, lacunae, risk involved, right? Okay. So, what are those? Right, we're talking about this actually because right now, whenever you access any resource over cloud, we are doing it all via internet, right? Okay, so shortcomings or limitations of using this internet. First thing is that any resource, when you try to access via internet, longer the geographical distance you have, longer the geographical distance, slower is going to be the performance. Longer the geographical distance, slower is the performance. This is one thing. जितना distance ज़्यादा होगा because it does take time. Single geographically, if suppose we're accessing some resources in US, UK, which are almost on the other part of the earth, right? So obviously it is going to slow down. So slow performance. This is one thing. Second thing is that this internet is a heterogeneous network. Heterogeneous network का मतलब क्या हुआ? That you have connectivities, and connectivities are not homogeneous. They're not similar. Right? For example, you may be having a Wi-Fi connection at your location. Right, from your Wi-Fi to the ISP, you may be having some wired connection. Right, from here you ISP to the next ISP, some satellite connection. Somewhere you have copper wire, somewhere you have fiber optic links, and so on. So medias are changing, and different medias they have different performances, right? So again, it impacts. It's a heterogeneous network, right? Next thing is that see, connectivity is all via router. Longer the distance, I told you, but again, another thing is that whenever you are connecting one network to another network, routers are there, and routers are layer 3 devices, right? So drawback with this router is what? When you're using something, they are must, right? But the negative side is what? That more the number of routers you have in your path, right? Slower is going to be the performance once again. Why? Because the router is a layer 3 device. So every time, now suppose this is your router, right? This is the signal, limit for the signal which is flowing through this media connectivity. So when the signal is received by this router, so router is going to process this signal at layer 3, right? Meaning it understands the layer 3 specifications and then it makes these routing decisions, right? So signal is received by this router, router extracts the signal at layer 1, right? Formulates the data, gives it to the layer 2, right? From layer 2, data is further given down to the layer 3, where it understands the layer 3 specification. For example, here it is the packet specification is packet. So router is ultimately going to process this packet, right? Based on the addressing details. This packet has got source IP, destination IP. Router is concerned with the destination IP. IP आपको पता है, it consists of two parts, network address and host address, right? Router is concerned only with network address part, right? Look up for this network there in the root table, right? Make the routing decision, then which way the signal needs to be forwarded. Once decision is made, then again reverse cycle start. From layer 3, packet is given down to the layer 2, and then from layer 2 it is given down further to the layer 1, where it is back to the signal. Yes. So this much processing takes place at every router. जिसे हम बोलते हैं hop. So more the number of hops you have this way, similar kind of processing is happening. Slows down your performance, right? Moreover, according to the OSI, because these layers are OSI layers, higher you go in processing, right? Meaning higher layer processing, meaning slower is the performance. Higher layer processing, right? Lower you keep it, faster it is going to be there. This is going to further slow down, right? जितना आप layered approach में processing के लिए ऊपर जाओगे उतना ही, so layer 4, layer 5, if suppose something we have at layer 7, so it is going to further slow down your processing. Lower you keep it, faster it is, right? For example, if I compare it with layer 2 communication is switching, layer 3 communication होता है routing. Initially I told you, so switching is always faster than routing, right? So higher you go in the OSI model for processing, slower it becomes, right? More the number of hops you have in your connectivity, slower it becomes, right? Longer the distance, slower it is, right? Apart from this, just because this network is public network, so as we know that this is highly unsecured network. Unsecured network, right? That is inherent nature is that it's not secure. And whenever you are using internet and something crucial, some crucial data is there. So you have to think of various security mechanisms here, right? Maybe you are using VPN connectivity, you are using various different encryption methods and protocols. Like for example, you do browsing, we are using HTTPS, right? So many mechanisms we are using to ensure security, because inherent nature of internet is it's not secure, right? Then further, if I talk about in general the performance, these are all shortcomings, but in general performance, if you talk about, we won't be saying that even after so many things performance is bad, but the negative side is performance is highly unpredictable. You get good amount of bandwidth also, right? But it is bandwidth performance. It is unpredictable, right? Why? Because traffic is uneven, right? Morning hours, evening hours, some peak hours are there when you will find that bandwidth is not that available, highly congestion is there. That's why it is unpredictable. So these are certain points because of which we really have to make a decision, right? As long as this is something, all these units are affordable. For example, right now we are conducting our class, virtual class over this internet. It's manageable to a greater extent, right? But if suppose I have some crucial data, my company's data, which is very, very important, very secure, so that's not affordable to extend it over the open network like this, right? So this is one thing what we have been using. Now, when it comes to cloud, you have some resource, right? This is suppose your web server, and you are here right now. you as a user, right? So you have two approaches now to access this web server. One is what I have been talking to you. This is your internet, right? But you have another approach also, or other option, that is your cloud. This is your AWS cloud. So if suppose you try accessing some resource, some server via internet, I told you what are the limitations. Now, in comparison to this cloud service provider, it says that if you want to access any crucial resource like this, so why don't you use my cloud, right? Use my cloud here to get access to this resource, which is much, much secure, which is not public network, it's private network, right? It's not open to everybody. Other few selected users, subscribers, customers, they're going to use it, right? Moreover, infrastructure is highly redundant, right? You have redundancies almost at every level, device level, rack level, or connectivity, zone level. All systems are there, right? So it provides you scalability, durability, security, high availability of the resources. All such stuff is there. So provider says, why don't we use my cloud, which is highly secure? Whatever drawbacks are there, whatever shortcomings are there in this internet, that's not here. You have dedicated bandwidth, fiber optic links, homogeneous connectivity, right? Almost no routers in between. Almost everywhere. We have direct connectivity. US, UK, Australia, they have direct links. We don't have much of hops, right? So this cloud is going to be much, much faster. It's just like using an expressway as compared to your old roads, old highways, right? This is a kind of expressway wherein you can drive at full speed, right? Much more secure kind of thing. So use my cloud. That is the whole idea, right? Only thing is that somehow you as a user, you have to provision to get connect to this cloud somehow from your location, from your network setup. कैसे भी करके आपको cloud से connectivity establish करना है, right? Maybe to reach to this cloud, if suppose distance is not much. For example, if suppose I'm trying to stream data, right? I'm watching a live movie and my server is there in US, right? So it's not at all affordable to stream the data from US down to India here, right? That's not advisable, or that's no guarantee of good performance. But if you use the cloud, so somehow you have to get connect to this cloud. Maybe you are using a lease line, maybe you are using some internet. For example, I'm sitting here at location Pune, right? And to get connected to this cloud, I have to reach only up to the Mumbai. So I can use even the internet, because accessing some resource via internet up to the US and accessing some resource via cloud, and I'm using internet only up to Mumbai, right? Mumbai is hardly 200 kilometers from here, not even that. So get connected by cloud somehow, and once you're connected here, then rest is high-speed backbone network, right? And you can ensure faster access of the resources, much multiple times faster than traditional internet. That's the whole idea, right? So for this, provider, what it has done is in its cloud, automated like this, right? This is some resource. This is your web server, suppose, here in UK, right? Cloud infrastructure is there. I am here right now in India, okay? If suppose I try to access this web server, which is there somewhere in the UK, so if I go traditional way, meaning via internet, so my request goes from this router to this router to this router, and we have got about 10, 12, 14 routers in between, right? Till I actually reaches to the destination, what Amazon calls it as origin. This is origin, right? So I told you the limitations here. But if suppose I'm using this service, which one? CloudFront. So for the Availing this CloudFront service, what Amazon has done is it has created certain connectivity points in the cloud. They are known as POP, point of presence, point of presence, also known as edge locations, edge locations. Right? These edge locations are different than zones. They're not zones, these are edge locations. So somehow you have to get connect to the nearest edge location. For example, if I talk about India, so in India actually we have, as of now, we have two regions now. Right? Mumbai is one region, Hyderabad is another region which has just started few months back. But we have edge locations, right? One of the edge location is there at Mumbai also, one is there at Delhi, other one is there at Calcutta. Like this, about 3 or 4 locations are there at locations which are connectivity points. Right? So if I'm using CloudFront service, so what will happen? As a user, I'm getting connected to the nearest edge location according to my geographical presence. For example, if I'm here in Pune, so my nearest edge location could be Mumbai. So I'm getting connected to the Mumbai to get access to the cloud. Once I'm connected, so rest is all the infrastructure of provider. So this edge location. Now this edge location consists of buffering servers, just like I discussed last time about the SQL servers. So just like that, here we have the buffering servers, right? These buffering servers are going to buffer the information, of course. So as soon as I make a request, let's say for some web content here on this web server, so my request is going to be taken up by this edge location, and on my behalf, it is going to forward the request to the origin, right? And whatever results are there, it is going to fetch back those results and buffer it here on the buffering servers, right? And then gives me the result back as a user here. Now, for the first time, this performance may be just like as I'm getting it via internet for the first time, right? For the next time, if suppose similar content are requested by not only me, but any other user in any part of the world, right? Anywhere, whether that fellow is there in US or UK, anywhere, make the request. So this fellow is getting connected to the nearest edge location depending on where the user is. And as I told you, information is all going to be buffered, not only on your edge location, rather all edge locations across the globe are going to be buffered with the similar content, right? So when these edge locations are buffered with the same content, so combined together, all these edge locations makes your CDN, content delivery network. Content delivery network is the collection of edge locations all across the cloud, right? Which is caching the similar results. And now with this approach, any user in any part of the world, when it uses the CloudFront service, so based on the geographical location of that user, that fellow is getting connected to the nearest edge location, and from there only it fetches the results back, speeding up this entire delivery process much faster. That is your request going all the way around via so many number of hops to the destination, which may be on other part of the earth. But this time, this is going to be delivered to you from your nearest edge location with minimum number of hops, right? If your edge location has the content, it will deliver it. If it doesn't have, so it is going to make the request to the origin, fetches the result, right? Caches it there in the buffer. Not only at this location, rather all the edge locations are going to be buffered with the several contents, right? And now any user, those users who are using the CloudFront, they are getting connected to the nearest edge location, getting the information delivered very fast, very smooth, much faster. That's the whole idea, right? We're trying to reduce the lacunae, the shortcomings of internet somehow. Right? Internet is in itself, it's a cloud, but this cloud has so many shortcomings, risk, right? Just because it's a public network, it's a heterogeneous network, right? And it's unplanned network kind of thing, right? नेटवर्क इंटरकनेक्टेड दुनिया भर में जो भी नेटवर्क हैं जैसे भी हैं सब आपस में इंटरकनेक्टेड हैं. That's a cloud. That's the internet cloud. We also call it. But if I talk about the Amazon cloud, it's well organized, right? It's secure, it's redundant, right? It has n number of features. There's the reason we are opting for the cloud. Yes. Is this clear? That's the whole idea. So if we go by point of this. So CloudFront is a web service that speeds up distribution of static and dynamic web content like HTML, CSS, JSON, image files to the users. Web content, whether it's static or dynamic. CloudFront delivers content through a worldwide network of data centers, what as locations, right? So remember, as locations are different than the zones, availability zones. In traditional networking, I told you, right? Yes. So traditional networking में क्या हो रहा है? User requests will be routed from one network to another. So the complex collection of interconnected networks that comprise the internet until the content is found. I told you, hop to hop, router to router, your request goes. Using AWS backbone network dramatically reduces the number of networks or number of hops, which improves performance and provides higher data transfer rates with a reduced latency. Latency means delay. When a user requests content through CloudFront, the user is routed to the edge location, closest edge location that provides the lowest latency. Closest मतलब जहाँ पर latency सबसे कम मिल रहा है, so that the content is delivered with the best possible performance. CloudFront is a good choice for distribution of frequently accessed static content. Frequently, देखिए ये important है यहाँ पर. वो content जो frequently accessed है, then only it makes some sense to buffer them. Otherwise not. You're trying to access the content really in a month or so, तब इसका कोई फायदा नहीं है. So frequently accessed static content that benefits from edge delivery, like you have popular website images, videos, media files जो ज़्यादा bandwidth consume करती हैं. Now videos or images ये bandwidth consuming जो है कहना चाहिए applications हैं या products हैं, right? Software downloads. If the content is already there in the edge location, so CloudFront delivers it immediately. But if the content is not there in the edge location, then CloudFront retrieves it from the defined origin. Origin हम पहले ही define कर देते हैं, right? जब हम ये CloudFront service configure करते हैं, so we are going to define the origin. Origin may be your S3 bucket हो सकता है, because S3 can be used for hosting web contents, website, right? वो आपका web server भी हो सकता है, right? That is configured as a source for the definitive version of content. ठीक है. बाकी benefits काफी कुछ आपको समझ में आ गए. CloudFront provides increased reliability and availability. अब स्पेसिफिक अगर टेक्निकली देखा है तो एडवांटेज क्या हो सकता है? Reliable and highly available. Right, reliable इसलिए because it's all cloud. Available इसलिए because we have redundancy now. Copies, multiple copies of the objects are held on multiple edge locations around the world. So whenever you have the content stored redundantly, availability increases, right? Because अब ऐसा नहीं होगा कि user जो हैं they are going to contend with each other from a single source. Rather, contents are distributed, and if it is distributed, so they are highly available now, right? Moreover, CloudFront keeps persistent connections with origin servers. एक बार आपने सेटअप कर दिया, so CloudFront जो है ये establishing the connectivity with the origin servers persistently, so that those files can be fetched from the origin servers as quickly as possible, right? CloudFront also uses techniques such as collapsing simultaneous viewer requests at an edge location. देखिए क्या होता है, मान लीजिए अभी तो मान लीजिए यहाँ पर 1000 यूजर्स हैं, दे आर मेकिंग द रिक्वेस्ट फॉर द सिमिलर कंटेंट शेयर, तो यहाँ पर 1000 रिक्वेस्ट आए, सो CloudFront क्या करेगा, इज नॉट गोइंग टू सेंड दोस 1000 रिक्वेस्ट टू द ओरिजिन, rather all those 1000 requests are going to be collapsed as one single request, right? Only a single request is reaching to the origin, right? और जो भी response आएगा, that's going to be buffered here, and then all those 1000 requests are going to be replied, right? Reducing load here on the origin. 1000 queries मतलब ये नहीं कि 1000 requests जो है origin पे जाएंगी, those are going to be handled by the edge location itself. Yes. So that is the meaning of collapsing simultaneous viewer request, right? For the same file into a single request, reducing load on the origin. CloudFront integrates with AWS WAF. WAF का मतलब होता है Web Application Firewall. जब हम बोलते हैं Web Application Firewall, meaning this is the firewall which is working at application level, right? So this is something inbuilt into CloudFront. So it can protect your web applications from attacks by allowing rules configured based on IP addresses, HTTP headers, custom URI strings. ये their specification है. So जो हम security करते हैं, usually we are doing it at layer 3, layer 4, at the most layer 5. But here WAF जो है, it provides you security at layer 7, right? Okay, बाकी key terminologies अभी आप समझ चुके हो. As location, this is a location where content will be cached, right? Different than zone. Origin क्या है? This is the origin of all the files that the CDN will distribute. जब भी हम CDN सेटअप करते हैं तो एक origin बताते हैं उसके लिए. अब origin आपका bucket भी हो सकता है, EC2 instance हो सकता है, load balancer हो सकता है, root 53 भी हो सकता है. Distribution मतलब CloudFront distribution, ऐसा हम बोलते हैं. The name given to CDN, which consists of collection of edge location. बहुत अच्छा practical example है CDN का. We are watching YouTube videos. बहुत अच्छा example है, right? उसमें ये technique हम use करते हैं, and there is the reason. Contents are, आपको पता ही, how fast they are, right? You will never experience any kind of delay. कभी आपने देखा, कभी delay नहीं आता, congestion नहीं आता, right? Performance is always best. Yes. तो ये हम सेटअप कर सकते हैं. बताइए, your questions now.
Yes, sir.
Is this clear? Right? छोटे-छोटे वो हैं. इसका लैब मैं आपको कल बता दूंगा. कल एक कंबाइंड लैब में लूंगा, और कल एक क्लाउड वॉच मुझे बताना है, और क्लाउड वॉच के साथ एक और SNS. दो छोटी-छोटी सर्विस है, तो तीनों को मिला के मैं एक लैब आपको शो कर दूंगा. राइट, तो कल हमारा आखिरी टॉपिक रहेगा, और टॉपिक का कवर. तो मिलते हैं सेम टाइम. ऑलराइट,
Thank you, sir.